And here, let us invite Martin Mellor from Ericsson.
Thank you. Dzień dobry. Let me start just by saying that Ericsson started the transformation in communication in Poland in 1904, 113 years ago. St. Petersburg, Warsaw were chosen as the smart cities of that time, and we put an underground cable system in to have communication in Poland for the first time. That was at the Pasta Building, Zielna 37 in Warsaw. Wind forward a number of years, Ericsson was leading with cellular communication, with GSM, with T-Mobile. The CEO is presenting later, so a nice connection there. Last year, Ericsson acquired Eric Poll, and with that came 2,200 software engineers that are developing software for the Ericsson radio system. So with that, I think you can see with our history, with the research and development, then we're well placed to play a major contribution for the 5G development in Poland in the future. Last year, we had the opportunity to host President Duda in Stockholm, and he visited our HQ. He advised us to focus on bringing together R&D, industry, academia, and startups to promote Polish innovation. And that's exactly what we've been doing as we go into 5G. So, 5G. It took us 100 years to connect 1 billion places with a fixed network. It took us 25 years to connect 5 billion devices on the mobile network. It's going to take us 10 years to connect 50 billion things. And this is the IoT of the future, which is going to be one of the main drivers of 5G. Industry are coming to the likes of Ericsson and service providers, and they're asking for some of these attributes of the network you see behind you. For 2G, 3G, 4G, it was service providers, it was vendors defining the standards so that we could have voice communication, we could browse the internet, we could watch video. But now industry is saying, I actually need a network that's different. I need multiple networks, and I need those networks to behave differently. I need low latency, I need higher throughput, I need much more capacity. And this is because these industries are going through their own digital transformations, and everything that benefits from a connection will have one. So you see some of the attributes associated with the 5G network here. In Ericsson, when it comes to behind the scenes for infrastructure, we're looking at use cases. We're looking at connected cars. We're looking at remote machinery, remote mining, remote operations. We're also looking at the business case for 5G. But of course, being a global R&D innovator, we are developing the 5G products, and we're bringing those to market now with partners and with service providers and with industry. So I wanted to give you just a couple of slides on what is behind the technology. How will we get much lower latency? How will we get much higher throughput and high capacity? This is a topic that could last for a long time, but I'll brief and do this in a couple of minutes. So we're looking at a common 5G platform network that will have the devices and the IoT on the right as you see it, or the left as you see it. We have the access and mobility network. We will have the core network for the service providers, and then the IT cloud. And I will focus in the next two slides on what's going to change in the access and mobility and what's going to change in the service provider core. So NR, we call NR, this is the next generation radio. Today's radios will be going up to around 3, maybe 4 gigahertz. You saw that from the previous presentation. Next generation we see is going above 6 gigahertz. And whereas LTE today will be the foundation for 5G of the future, there will be some nice enhancements with carrier aggregation, massive MIMO capabilities, a blend of licensed and unlicensed spectrum, and we will see that go up to 1 gigabit per second for LTE. That won't be enough, and therefore 5G will take over from that. And some of these key components are listed here. So we will have higher frequencies, we will have more spectral efficiency to increase the throughput. We will have massive beamforming and tracking No longer will radiation be scattered everywhere. It'll be focused on the device, much lower power, much higher throughput, and we will be having small cells and multi-site connectivity included as well. In addition, there will be access and backhaul combinations and integration and direct device-to-device communication. And of course, that device doesn't just need to be your mobile device, it can be cars, trucks, and other devices too. Ultra-lean design will come also. We will only communicate when we need to with the signaling, and this will preserve a lot of the battery life too. So some of the things you see here give us the higher throughput, the better capacity, the longer battery life, but low latency is really important with 5G. It is probably one of the defining changes that we will see. When you touch the internet, it sounds strange, doesn't it? When you touch the internet, we call it haptic feedback. And we're doing this now with remote gloves so that you can have remote operations, remote industry, remote mining in dangerous areas. When you touch the internet, you need real quick feedback. Latency down to 1 millisecond, or around that figure. So how will we do that? Well, we will have better signaling. The standards for 5G will bring around changes to the radio interface, but one of the major changes we're going to see is a 5G-ready core network. And this is going to mean a distributed cloud where low-latency services will be served by data centers that are probably 30 to 50 kilometers away, as opposed to today, where they may be 300, 500 kilometers away today. So the 5G-ready core is going to come virtualized, so we can have much more scalability and agility. It's going to come in a software-defined way, so it can be programmed. And it's going to come with this localized processing, so you can have the low latency in this distributed cloud. The other big important fact to consider here is that a 5G network isn't about radio, it's an end-to-end network. It's radio, it's the whole core, it's end-to-end from where the service starts to where the service is processed. And we call this network slicing, where different industries can take a slice of the network for the period they need it and have a guaranteed service level for that period of time. So segment networking is really a big part of 5G. So that's the technology. They're being developed now by thousands of engineers, many of which are in Poland. What are we doing with that technology? Well, we're taking it out to the field. We're partnering with service providers, we're partnering with industry partners, and with academia too. And we're actually doing many of these trials right now. A great demonstration on YouTube we did last week with Verizon in America was in Indianapolis on a racetrack with 5G. We got 6 gigabits per second, but that was just part of the story. The real fun was when we blacked out the windscreens of the car. The driver could not see a thing. But there was a video camera on top of the car, and he had virtual reality goggles, and we could send the video stream through the network, through the 5G network, and back through the virtual reality applications, and he could drive a blacked-out car on the Indianapolis track. So a really nice bit of fun. It was a bit like Top Gear meets 5G. But in Poland locally, then we are doing exactly what Mr. President asked us to do. We are working with our local R&D teams in Poland. We're working with startups, the new ecosystems, especially with narrowband IoT. We're collaborating with Warsaw University, AGH, and downstairs on the ground floor you'll see the solar boat that Ericsson is participating with AGH, and with Vuj also. And we're partnering with customers to bring some of this 5G technology to Poland as quickly as we can. And that, of course, is being supported by the government and regulatory and some of the messages you heard in the previous presentations. We do have a real golden chance for Poland to do something different with 5G. With 2G, 3G, and 4G, I don't believe Poland had the quantity of software engineers in the country that was needed to develop that, but I've been really impressed by the number and expertise of software engineers in Poland, especially in the telecommunications field. And now it's a golden chance for Poland not just to be a user of 5G services, but to be an innovator and to lead the R&D in Poland. So Poland can not only have a 5G network, it can be built in Poland too. My final slide is a connection and a handover to the next presenter. And Ericsson have been doing a lot of trials and partnerships with T-Mobile. And here are 3 examples, one of which is a track in Germany where we are showing connected mobility. Another one is for federated network slicing between Korea and Germany. And then we have a final one with smart grid solutions. It's really important that these trials and demonstrations show 5G will benefit society and have a positive business case. Thank you.